In this remaining part of section 1, I just want to pull out some algebra skills that maybe you're a bit rusty on, just to show you different tools and techniques you have in order to work these limits, because algebra is going to be the path that we take in order to work limits unless we are given a graph or a table, but those are going to be in a few moments. So let's look at limits with radicals. In order to work limits with radicals, what we're going to do is we're going to use conjugates. When we're talking about conjugates, we're talking about using the same setup of the grouping of the radical, but a different sign in between. So here's the given problem. Find the limit as a approaches 1 of 1 minus a over the square root of a minus 1. If you go and you plug in 1 to this, again, that's always should be your first set, straight plug in, you get 1 minus 1 on bottom, which gives you 0. So that's where you say, I better try something else. So when you have that radical in there, what we're going to do is we are going to multiply by a special 1. Since this problem does not have an equal sign in it, I have to make sure I'm only multiplying by a 1 so that I don't change the value of the problem. So that special 1 that I'm going to do is I'm going to multiply by, make this 1 a little bit bigger. I'm going to multiply by the square root of a plus 1, and I'm going to multiply by the square root of a plus 1 on top. The reason I want to do this is when I go to FOIL or multiply out that denominator now, it's going to cancel out my radical. If you consider that when you FOIL or multiply out that binomial times binomial, your middle terms are going to cancel, your square root's going to cancel, and we're going to get a denominator that's not 0. Now it does amp up my numerator. Great. My numerator is not my concern. It can be anything it would like to be. It's that division by 0 that causes me to get to a stopping point. So what I'm going to do is I'm going to multiply by this special 1, and again, I come up with this just by changing this sign in the middle from negative to positive. And I make sure I multiply both the top and bottom so that I have a big old 1 here, and I'm not changing the value of the problem. So we're going to go ahead and multiply this thing out. So this would be equal to, now we have not taken the limit, so I'm going to have to write the limit as a approaches 1 until I finally take the limit. Now on the top, I am not going to multiply out the top because it's not going to simplify or change anything, so I'm just going to leave it as is. 1 minus a times the square root of a plus 1. Now I am going to multiply out the bottom because that's going to be a game changer for me. So square root of a times square root of a, let's come over here and make a little side note. If I have the square root of a times the square root of a, this is really like a to the 1/2 if I rewrite it as a fractional exponent. And then if I rewrite this one as a fractional exponent, this would be 1/2. If you remember from Algebra 1 days, when you multiply these two together, when you multiply the bases the same, you add the exponents. So it would give me a to the first. We write that as an a. So if I'm multiplying the square root of a times square root of a, essentially those radicals cancel each other, so I'm just going to get a on bottom. Now when I distribute the square root of a to 1, I get plus the square root of a. I'm going to do negative 1 times square root of a, that gives me negative square root of a. Negative 1 times positive 1 gives me negative 1. You can see that these middle two terms would cancel. So I'm left with the limit as a goes to 1 of 1 minus a times the square root of a plus 1 all over a minus 1. Now you might be thinking, teacher, you did something wrong. You said we were going to get rid of division by 0 on the bottom. We haven't done that. Well, we're not done yet with our algebra. Notice this, there tends to be some similarities between this 1 minus a and this a minus 1. Those look real similar but not exact. And this is why it's going to benefit you not to multiply things out that are not going to simplify down. For me, multiplying this out simplified it down to a minus 1, but multiplying out the top wouldn't simplify it. But now that I have everything as multiplication, I can actually do some factoring and simplify. So what I'm going to do, again, let me make another side note over here. I'll do it in a different color so you can see it's different. If I have 1 minus a, talking about this one here in the numerator, and I take a -1, factor that away, that just changes all the signs to give me -1 plus a. Rewrite these, that gives me -1 parentheses a minus 1. So now I have that a minus 1 I would like. So I'm going to say this is equal to the limit as a goes to 1 of -1 a minus 1 square root of a plus 1 all over a minus 1. And because I have multiplication going on in here, I can cancel on top and bottom, which is equal to, still haven't taken that limit, a approaching 1 of -1 parentheses square root of a plus 1 all over, well, we canceled all that. So now I can evaluate. So this would be equal to negative parentheses square root of 1 plus 1. So that would be equal to -2. So you can see here, multiplying by the conjugate on top and bottom allowed me to simplify this piece and get rid of my radical. Factoring out the -1 and that a minus 1 allowed me to cancel now that a minus 1, leaving me with a simplified version or an alternate version of the original function that I was working with. Also notice this part. I wrote limit the entire way until I actually took the limit. So final answer for this would be -2, but all of this would need to be written. Now, these were just side notes. So this part would not have to be written as you're working your exam, but I wanted to show you the algebra as we go in so you could see this now. So then when you go to replicate this, you would know what steps to take and why things worked out the way they did, because as you're going to see in the next example, not all radicals are nice as square root of a plus 1. So let's look at this example, because you can see with this example, again, first step, you want to plug in your value that you're trying to take the limit at and just see if straight evaluation is going to get you there. You plug in 0 for x, and you can see you get division by 0. So we're going to have to use the process from the previous example in order for us to get there. And so what we're going to do is we're going to multiply by the conjugate of this. And so we are going to multiply by a big old fancy 1. And that big old fancy 1 that we're going to multiply by is going to be the square root of 5x plus 16 plus 4. Now, if I do that on top, we know some magic's going to work out like we saw in that last one. But we also have to do it on bottom, because multiplying this function by 1 is what's going to give me a new function that we can evaluate the limit of, but it doesn't change the value of what we were giving. Now, we're going to have to make sure we can work this out a little bit. So I'm going to go a little bit slower kind of as we do it, but I'm going to kind of not write some things too, if that makes any sense. And so all we're doing right now is multiplying by this big old 1. So this is going to be equal to, we have not taken the limit, so I'm going to say the limit of x as it approaches 0. Now then, when I work this out, I'm going to talk and I'm going to make some swoops here and there, but I'm not going to write all the pieces. We're going to kind of simplify as we go. So if I do this first radical times this radical, we saw in that last one, that just gives me 5x plus 16. And then if I do this square root times 4, gives me 4 square roots of 5x plus 16. But you'll notice that when I do the next multiplication of -4 times the radical, I now have the positive and the negative, and so those are going to cancel. Then I'm going to do -4 times +4, and so then that's going to give me -16 here on top, all over x times this grouping, and so we're just going to say x times the square root of 5x plus 16 plus 4, and I'm not going to distribute that part out. Now I can go ahead and clean up the top. This 16 is going to cancel with this 16. So I have equal to, we have not taken the limit. So I'll say the limit as x approaches 0 of 5x over x square root of 5x plus 16 plus 4. And then you will also see that that x is going to cancel. So I'm going to clean up that function as much as I can before I have to deal with this limit so it doesn't cause me any more issues. So I have 5 over the square root of 5x plus 16 plus 4. So see, it kind of paid off there too that we didn't distribute that x out because we were able to do some canceling like we saw in the last problem as well. Now that we multiplied by, again, by that fancy 1 right there, we now have it down to this function that we can actually take the limit of. So I'm going to say equal to, go ahead and plug it in. So I get 5 over the square root of 5 times 0 plus 16 plus 4, which is equal to 5 over the square root of 16 plus 4. So 5 over 4 plus 4 gives me 5 over 8. And so again, I want to do this example because it's definitely a harder radical to work out with the pieces, but I want you to kind of see how that worked out and how we can use that tool from algebra, multiplying by the conjugate of the radical, in order to get the function in a more usable format. Now let's look at this next example, and it's going to be limits with a fractional numerator. And so I want to show you a little bit of maybe some algebra tricks to help you work this a little bit quicker. So if you've never seen an algebra trick of putting two fractions together, let me do just a quick little highlight over here. Say I had 1/2 minus 1/7. Well, traditionally, middle school, you learn how to put fractions together and you find common denominators. Common denominator would be 14. You change the denominators, you work so hard and you put it all together. But there's a little trick that you can do in order to work this together. And I'm going to work this one and then I'm going to show you it with a more generic one. What you can do is you can multiply this way 1 times 7 to give you 7, minus, because that was the operation in the middle, multiply this way 2 times 1 to give you 2, and then multiply this way to get your denominator 2 times 7, which is 14. So that gives me 5 over 14 for a quick trick of putting two fractions together. Now let's do it a little bit more generically. Let's do a over b plus or minus c over d, because it doesn't matter if we're adding or subtracting. You multiply a times d. You add or subtract whatever operation you're trying to do. Multiply this way, b, c, all over, then multiply the bottoms, b, d. And this little fraction trick right here is going to be really handy, especially with our functions and having all these different variables and not having to figure out a common denominator, especially in more complex fractions. And this will get us there a little bit quicker. So I'm going to do that here. I'm going to multiply this way. So I'm going to kind of clean this up. This gives me the limit as x approaches 5, because if you straight plug in 5, you get that 0 on bottom that we don't want. Multiply this way, 1 times 5 to give me 5, minus multiply this way to give me x all over, multiply across the bottom, 5x. Now this is being divided by x minus 5. So if you remember how to divide fractions, you'd have to say keep it, change it, flip it. So I'm going to keep the first fraction, which is 5 minus x over 5x, change it to multiplication, and flip that second one, because this is really over 1. You can put anything over 1 and it remains the same value. So I just flipped it over. So now I can multiply across the top. That gives me the limit as x approaches 5. Don't lose your limit notation. So that gives me 5 minus x over 5x over x plus 5. And then we're going to do that same factoring that we did earlier in this section. So x goes to 5. And I'm going to factor a -1 out of the top. So that gives me an x minus 5 on top. So don't be hasty and try to cancel yet. Make sure it looks completely the same before you do it. So this will cancel with this now. And we're now at the limit as x approaches 5 of -1 over 5x. That we can take the limit of, and we get a final value of -1 over 25. Now when you're working a problem like this, don't forget, again, limit notation. Limit had to carry itself the entire ways of the equal sign until we got to this point and we were actually plugging in that limit. So be careful of notation. I do grade meticulously when I go to grade limit problems. Let's continue on with some algebra skills that we need to pull up from the dark corners of our knowledge and make sure we understand how to work with them. The next kind of algebra tool I want to look at is one of limits with cubes. And so let's remind ourselves of a couple of things. First of all, first step, try and evaluate. You try to plug in 3 and you get 3 minus 0 on bottom, and that doesn't work out. Now remember, this is a fraction, and fractions mean to divide. And so since we have an x minus 3 on bottom, let's pull up some of those dividing skills. And what I'm going to do is I'm going to do synthetic division. You could do long division, but since I have an x minus k on bottom here, we're going to go back to pre-calc, college algebra, all those fun days, and do a little synthetic. Now you remember synthetic, you put the 3 on the outside, and then you divide this, and you only put in, you only put in the coefficients, and so that would be a 1, -2, -6, 9, in descending order from the exponents. You bring down the 1. We're just going to do synthetic real quick. So put the 1 here. You're going to multiply 3 times 1 to give me 3, and then you add, so it gives me positive 1. Multiply, that gives me 3, add, -3, multiply, -9, add to give me 0, which is my remainder. So this works out really nicely the way this one divides. If you need any additional resources with synthetic, it's been a while, you forgot kind of the ins and outs, shoot me a Canvas message. I'll give you some resources to fill in there. But what this gives me is, when I divide this out, this is going to be equal to the limit as x approaches 3 of, since I divided out, here's my result now, x squared plus x minus 3. That I can go ahead and now take the limit. So that gives me 3 squared plus 3 minus 3. Don't miss it on that last step of arithmetic. So let's see, that gives me 9 plus 3 minus 3 cancel each other. So 9 would be my final result. So again, another algebra skill we need to pull out. In order to work this limit, we had to pull out some synthetic division. When faced with a problem, first plug it in, see if it works out. If it doesn't work with straight evaluation of your limit, then pull some of your algebra skills to see what you can do from there. We have multiplied by the conjugate of a radical. We have just did some algebra with fractions, and here we had to pull out division. Now this next one may have been a while. If you remember this all the way back from Algebra 1, the sum and difference of cubes. So if you have the sum of a cubed plus b cubed, you can break it apart and pull out an a plus b and reduce it down, or likewise with the difference, and then you can pull out an a minus b and break it down. So I'm going to use this algebra tool, and this is not one you really use a whole lot, so I want to kind of pull this out from the depths and see how this can help you with this. And so for this one, we're going to do some factoring. Again, you straight plug in -2, that doesn't work out. So you try this, and we're going to say, let's let the limit as x approaches -2, and let's factor the top. That is the difference of 2 squares, which you should know. So factors into x plus 2, x minus 2. Got to be sharp on these factoring skills. Now the bottom is going to be, this is x cubed plus 2 cubed. And so your a would be your x, and your b would be 2. So we're going to use that yellow form there to break this apart. So this would result in x plus 2 times x squared minus 2x plus 4. Now this works out really nicely because now these x plus 2's can cancel, and we'll have the limit as x approaches -2, and our result was x minus 2 over x squared minus 2x plus 4. And then from there, we can plug in our -2. So when you plug in -2, that gives me -2 minus 2 over -2 squared minus 2 times -2 plus 4. Don't miss it on your arithmetic. So this gives me -4 over, let's see, that would be 4 plus 4 plus 4. So I get -4 over 12 So I get negative 1/3. And so that works out really nice. But this right here, it's probably been a while since you've seen some of those sum and difference rules. But as always, all this algebra is just going to help you to be keen on what you're doing here. If you need any additional supplements or resources, please reach out sooner than later and let me help you fill in some gaps if you're missing them. Hope 1.1 goes well.